Welcome to Genome Design, where today we're going to take you through the process of our very popular Stage 1 Plus package for the Cayman 718 GTS 2.5 litre. Now, the 2.5 litre GTS performs really well with just our Stage 1 package on it. However, lots of customers are looking for just a little bit more noise out of the car. So what we did was we created a 1 Plus package that includes our GD Sports Cat. Now, that removes the GPF but keeps the cat in place so it's still able to pass a UK MOT. Now, by doing this, we don't only improve the noise of the vehicle, but it improves the flow over the standard setup. What that means is that we can actually push a little bit more boost, a little bit more ignition timing as a result of better exhaust gas flow, and we're able to produce slightly better power and torque figures. Right, so you've seen the lads load it up. If you've seen these videos before, you've seen us load a million cars onto the dyno and talk about the graph. But it might be your first point of contact with us. And in this case, I'm going to go through the stock graph. If this bit isn't for you and you don't want to see the stock logs and all that stuff, we will cut it in so that you can go straight through to where we end up with the tuning. So, without further ado, we will look at the stock figures. Exactly where you'd expect it to be, 323 wheel horsepower. I'll calculate that in a minute because I'm going to need to get my calculator out. But bear in mind this has got a sports cat and BMC panel filters, so it's probably just a little bit over what we would expect from standard. It's doing 303 foot-pounds and 323 wheel horsepower. Again, must touch on the fact that these graphs on the 2.5 litre cars are actually really good in comparison to the 2 litre, which if you've seen that video, the stock calibration on that car is god awful. So as a off-the-shelf tune, if you like, straight from the manufacturer, this is pretty good and it's really consistent. It tells me that everything's healthy with the car, but I'm still going to go and have a look at where it's at in terms of what boost pressure is it making, is it pulling any timing out stock, what is the ignition advance on this car, have we got a wide open throttle, all that sort of good stuff. So we'll touch on that in a moment. And then I will build a base file. Now, my intention is to lift things up incrementally. We may film the first base file and then if we don't hit the numbers that I want straight away, if we go again, we'll just keep filming it. If that gets a bit long and tedious, we'll cut it all in so as you can see where we're at. If you want to skip all the good stuff in the middle and go straight to what was the difference between stock and our tune. So let's jump across to the laptop, take it from there, and then we'll go ahead and show you the base file. So what we've got here is the stock data logs. Obviously you've seen the car run the dyno. Again, everybody gets hung up on dyno results. The reality is from a tuner's perspective, what we're looking at is the data. So we've picked a whole bunch of channels here that we want to see that the ECU outputs that information to the RAM logger that we've got, which then saves it into a run like this that you can see on my screen. So I'm not going to go through all of these because it just takes us forever. But the basics that we need to see are throttle position, actual value. So whilst it says 81% on there, I'll show you in Winholes in a moment, that means 100% relative to the pedal position. And what we're looking for is big dips in this. So what typically this ECU will do is if it sees something that it's unhappy with, it'll try to adjust the wastegate. So for example, a boost overshoot. If it's overshooting its boost target by more than the allowed amount that's in the software, it'll close the throttle as a result of not being able to control it with wastegate movements. It'll shut the throttle to try and stop it overshooting its boost. If it still fails to stop it from overshooting, it will then put the car into limp mode because it'll hit an upper limiter. as we can see here, you've got absolutely no dips in this. Now compare that to a 2 litre graph and it's absolutely, I mean, a 2 litre Boxster Cayman 718 graph with the throttle control is god awful, and you can see that in the dyno graphs. So we've got full wide open throttle, so that's good. You can see that the upper RPM limit of this car is 7,456 standard. The next thing that we would need to see is pressure. So we've got set points, which is this one, and then we've got pressure actual. Now there's an allowed amount of deviation from the set point to the actual boost pressure, and that's how you try and keep the boost control really tight, but you have to have a certain allowance, otherwise you'd have too many wastegate movements and too much throttle closing, because it's bound to not be completely perfect every time. So what we've got here is down at the bottom where it comes on boost, we're aiming for, we've got a bar of atmospheric pressure, that's why it says 1,838. That actually means it's less than a bar, so you've got 838 millibars. It's allowing it to make 913 millibars, which is basically hitting its deviation point now, so it's not going to create any issues with the overall drivability of the car. As the car goes up the rev range, it makes its peak cylinder pressure right around here, and then it slowly introduces more boost right up to the top. Now, absolute maximum boost pressure that we're seeing is 1.12 bar requested and 1.183 actual, so it's perfect. It's just not enough, and that's where, first things first, we need to look at the boost pressure, and then we'll start to introduce ignition timing. Now, the next thing that we would need to check here is it pulling any ignition out as standard? Because if we start to introduce more ignition timing and more boost and it's pulling it out standard, all that's going to happen is we're going to add more to it, it's going to pull more back. So the ignition knock control here is the first 4 there. And as you can see here, these lines would have, again, big dips in them if there was any knock control kicking in. And as you can see, all the way through the rev range, they've got 0, 0, 0, 0, not pulling any ignition timing at all. On a tuned file, anything up to about 3 degrees, I don't worry about, especially on the dyno, because the airflow, the way that it works, you probably find if it's pulling 3 degrees on the dyno, it'd be pulling 1 or less on the road. So it's sometimes a good indicator for us to see how close we are to the knock control limit. So we can keep adding timing until we see it pulling that 3 degrees back. Then when you go out on the road and it allows it to add that timing because the airflow is better with the engine being in the back, what you tend to find there is that it'll actually make more power on the road than what it shows on the dyno. All to do with airflow and keeping it cool, because the engine is in the back, unfortunately, from a cooling point of view. Next, we need to see the fueling tables. I mean, again, I'm not going to go too deep into this. It's not something that we need to see loads of, but everything has a set point and an actual value. So in this particular case, all we need to do is check that we've not got any sort of crazy changes. So if it's requesting 0.89, which is lambda set point 1, that's lambda bank 1 and bank 2, which I've got there. You don't need to see both, but yeah, we check bank 1 and bank 2 because you've got 2 sets of lambdas. We're requesting 0.89, it's hitting 0.88, there's nothing funny about that. It's asking for 0.88 at the top and we're sitting right around 86, 87. That's perfect. It's absolutely fine as it is there. So everything's healthy from factory. Next thing that we would check is, how does the ignition trace look? Again, this is where it starts to add ignition timing. You can see as it comes on boost, if I just open the boost, there we go. As it comes on boost, the timing drops as it meets peak cylinder pressure. And then once it's settled down, it starts to add timing and boost right up to the top there. And we've not got any crazy dips in this anywhere. It all seems very happy. That sort of corresponds with the dyno graph, because if you've got any big dips in ignition timing or big dips in boost, you're going to see that in the torque and the power curve on the dyno graph. There are some other things in here which I'm going to check off camera because we could go on forever, but ultimately we're going to move across onto building the tune file. Now, as it happens, I've built quite a few of these before. I haven't got an extremely close match, but I have got a reference point from a Stage 1 Plus that I've done on a GTS previously. It's different software version, so it's not ideal. I can't just start with that file. I do have to build it from the ground up, but I've started to do that here, and some of the things that I've already started to do should result in a relatively good starting point. Now, what I've done is this ECU is based on torque request, which feeds into MAF tables, which gives you the boost. So what I've done as a starting point, rather than going to the top line of the torque request limit, which in turn gives you the most boost that's available off the MAF tables, I've actually come back a little bit from there, and I'm going to make a start just a little bit lower, and then I'll increase it as I go. So I've done all this. There's a whole bunch of, there's about 50 different tables that I've changed already, including upper limits for boost and things like that, set points for the boost controller. And then I've added some ignition timing. Now I've only added 2.62 degrees of ignition, and I've based that off various different models that I've done, but this one in particular, because I've already got a tune that I've sort of built out already on the dyno. I can see previously I've added 2.62 there. I'll start with that, see where it goes. I've added a little bit of boost pressure based off the torque requests. So we'll send this across to the lads, see where they get with that. We'll move on to the next set of data logs, and if it's all looking very promising, I will go back into the torque requests and the put table set points, and I will make some changes to add more boost pressure. If we hit the upper limit of the MAF tables and we want more boost still, then I will need to go across to these MAF tables here and make some changes to the upper limit of MAF, which is 600 Newton meters of torque internal engine request. So I'll need to add some extra here and then blend it down to here, so as it comes on boost it's a nice graph. I'll send this across to the guys now, get them to run it up and see where we go from there. So then we have run the car with my initial base file on. Now, as I described previously, we wanted to run this car in incremental stages. So we're going to film this, whether we put it into the final cut, depending on how many minutes I rant on for about the tuning. What you can see here, we've revved it out a little bit more, as you can see, and we've held the extra power. But what we've achieved overall, in reality, for like a stage 1 car with no hardware on, I'd probably be happy with that. I would like to turn it up a little bit more, given that we've got some hardware on there. So we've gone from 323 wheel horsepower to 380 wheel horsepower. So it's still a really good gain. And we're sitting right around 380 foot-pounds as well. So we've more or less matched the torque to the output of power. Again, it's a considerable jump over standard, but given that this customer spent a little bit of money on hardware, what I'm expecting to see here is that we've increased a little bit of boost pressure, but we've not had to pull any timing out as a result of heat. It's really consistent on this tune. We've done multiple pulls, which you've seen. This is just an example to show stock versus the first tune. Now, where I'd probably like to finish with this car is somewhere around 400 wheel horsepower and ideally above 400 foot-pounds. However, the thing that I can tell from listening to the car running on the dyno and having seen the pipe diameter for the catback exhaust system on this car whilst it's been on the ramp, I can hear that it's restrictive. So what tends to happen now is if we start to introduce more boost in the bottom end here to get more torque, what we end up with is a car that sounds like a jet engine for a start, because there's too much back pressure in the exhaust system. But more importantly, that creates heat. So yeah, you might hit a peak torque figure, but everything starts to get hot and you lose all the top end. So you've got to try and find a balance between the two. So if we were up at around up to 400 foot-pounds, 390, somewhere around there, and around 400 wheel horsepower, which would suggest the car at a 10% correction factor is pushing 440. Most people use 12 to 15% on a 2-wheel drive. I tend to underquote, and then obviously customers that go to external dyno days and things are not disappointed with the result. So what I need to do from here is go and have a look at the data logs, see how much the changes that I've asked for, how much boost have we introduced, have we got any timing pull, is it doing anything to the fueling, yada, yada, yada. Once we move onto that side of things, I can understand if I can ask for any more. I'm hopeful that we can, based on my previous experience on the videos that you might have seen before. I've done one of these, albeit that car had a Miltech exhaust system on it, which the pipework is considerably bigger. So that car may actually have done more, I don't know yet. We'll look when we finish up on this one. So I'll now jump across to the laptop. We'll do a little bit of talking about that. I'm not going to go too detailed on it because it's, you know, it can get a little bit in depth, and we could be running on for an hour's longer talking about data, where really what people want to see is running the cars up and things. Let's see where we get to with that, and then we'll build another revision for this car. So obviously you've seen that we've run the initial base file where I'd kept everything just a little bit turned down. Very briefly going to go through these logs just to see where it's at and see whether we've got some room to turn her up a little bit more. So I'll put a few things on here rather than going through it individually, because you've seen all this before. So what we've essentially done is gone from, if I open up this log here, so it was making just short of a bar there previously, up to 1.189. What we've got now is we're now making another 100 millibar on top. So it's not vast amounts, but we've gained a little bit all the way through, and then right up at the top we've added right around 400 millibars of boost. So that's what's given us the really good you know, peak figures. It's the torque that I would like to lift up at the beginning of the run, which you can see here. So we can see that's looking pretty promising there. In terms of ignition timing, we've got a lovely ignition timing trace there. Naturally, it's making a little bit more timing, even though, because we've not added loads of boost. How this usually works is, as you go up the boost table, you go along the ignition table, and there's less ignition standard. So if you just added boost, what you'd find is it make less ignition time in it, then you need to add the ignition timing. So because I've been able to skip that bit of the process because I've done one before, we can we're making a similar amount of ignition timing as the standard file, but with the additional boost. So it's doing what I would have expected it to do. In terms of ignition timing, is it retarding in it? We may see a little bit, 3.75 there, and then nothing at all. So as it makes peak cylinder pressure, again, as I said, anything around 3 degrees I'm not worried about. And if you open up the boost, you can see it's literally pulling that little bit of timing out there as we hit the sort of, as it comes on boost and it creates cylinder pressure, it pulls the ignition timing out there, and then all of a sudden you find it drop back down and it's happy with where it's at, and you don't get any more. There's 2.25 right at the top there. So I'm not worried about any of that. That's all perfect and I'm happy with it. It's doing exactly what it should be. In terms of fueling, we've made some small adjustments to the fueling in the mid-range because we're now asking for more boost pressure. So if I just check the set point versus the actual, what we've got there is, again, we are looking good. We've gone from where it comes on boost, it was almost at lambda 1 on the stock file, so we've started to add the fuel in just a little bit quicker because we're adding more boost. And then down the bottom here, we're now requesting 0.83, 0.82, and it's doing exactly what we want it to do. So we've added a little bit of fuel, but with not crazy amounts. It didn't really need it for what we were trying to achieve there. We've not got a whole bunch of timing retard. We've got really good timing trace. We've got good boost pressure. Everything's looking pretty good there. Throttle position, sorry, that's torque. You don't need to see that one. The throttle position in the actual throttle position. Again, we've got no dips at all in the throttle position, so that's really good. And you can see if you look here now that we've actually revved the car out to 7,616. So it's picked up about 200 RPM of overall range as well. With that in mind, I'm going to check some other things here. I've got things like turbo speed sensors, cat temperatures. There's a whole bunch of things that I need to look at to decide. But from the basics there, I'm happy to turn this car up a little bit. So again, what we'd do is jump across to Winholes. We'd make the adjustments to the. We don't need any more ignition. We may even look at just pulling a little bit of ignition back around this area here where it's pulling it out. before we introduce any more boost in that area, or we keep the boost very similar here around that area and fill that gap with timing, and then start to introduce more boost at the top. I'll make that decision when I look at it into a bit more detail, but the first thing that I'm going to do is look at where are we? These torque tables here. So I'm going to increase the amount of torque request from 3000 onwards to give us that extra boost pressure, because that will feed into the MAF tables. So I will make those changes, send them across to the guys, load it up, run it again, let's see where we're at. If it's a little bit too much, then we can back it off to where we are. And overall, I'm happy with the base file. I'm happy with the results from the base file, but I do think it's got a little bit more to give. Now, before we jump across to the before and afters and all that sort of stuff, I've just said to Steve, who's filming me, let's just stop and take a moment to appreciate this particular graph, which you don't usually see. This is basically what this is called is a delta graph. So when we've made some changes, for example, it gives you all 6 runs are on here. Now, I know that's hard to tell really, but that's why I wanted to talk about the graph, because what it gives you is a delta between the two, so the worst and the best runs. Now, what we would usually use this for is and I can open it so that you've got stock runs times 3 and then tuned runs times 3, and you can get a delta between the two. So you can say it was doing 300 wheel horsepower, now it's doing 400 wheel horsepower, whatever. But what I like to use it for sometimes, as you can see here, I'm running in 5th gear. I've done 6 back-to-back pulls on this car, so that's 6 loaded dyno runs over 12 seconds from 1500 RPM to red line. So you can imagine that's like you driving down the motorway, holding the car at 1500 RPM, applying load, letting it go and sweeping it right through the rev range. That is the way to create the most heat, put it under the most load, and ultimately to show how consistent the tuning is. As you can see here, we've got such a fantastic result, it's almost impossible to tell that you've got 6 dyno pulls back to back showing there. But the delta between best and worst runs is 397 wheel and 405 wheel. Now, what I did let it do on the last run, I kept the exhaust gas temperatures up a little bit so there was some heat in the exhaust, and allowed the intake temps to be cooled down a little bit to get what we call a halo run. So typically we were seeing maximum about 400 wheel versus 397. The extra 5 came on the very last run, which is what it's showing here. And you can see it just up here, look, if you zoom in there, you can see that blue run. It just allowed it to make a touch more timing because I kept it cooler from an intake point of view, but allowed the exhaust to just be a little bit hotter, which they tend to like. Same goes for the torque figure. Again, don't mind this, that is, I'm going to show you again in a second. This is squashed, so you've got to imagine any small bumps or anything like that in the actual dyno graph is really exaggerated here. So you can see something like this on this screen, and then when you open it in the large screen where it's showing you the whole run individually, it evens it out. But what I'm most intrigued about here is that yet again we've seen somewhere between 6-7 foot-pounds of torque difference. That's really impressive. Usually what you see is if people are pushing them too hard, you'll get one run that's a real fantastic sort of halo run, if you like, and then as things start to get hot and it backs off and backs off and backs off, you get no consistency. So I could take this car now and add some more boost up here to bring us up above 400 foot-pounds, but it's going to become inconsistent. It's happy where it is. We're not getting massive intake temperatures, which is why we're able to get real good consistency. The more boost you introduce, the more back pressure you create, the more heat you create, the more that we're going to find inconsistencies. I'm happy with where this is now. With that in mind, we will now jump across and have a look at some of the stock versus tuned runs. But before we do that, just to show you my pointing case, as you can see when we look at the actual final run here, that little bump in the torque there, it's virtually nothing when you're actually looking at it in a bigger scale. It's because it's squashed. So what we've got there is a really fantastic end result. There's literally nothing I could do better with that, so I'm happy with it. I'll go across now, have a look at the laptop, check the data logs. I've just done 6 back-to-back pulls and data logged all of them, so I'm going to go through those individually, but I'll pick out this particular run so that you can see from a reference point of view what the difference is between stock and tuned. Lastly, I'm now going to talk about the previous tune versus the, well, I'm going to call the final tune. Now, I'm not going to rattle on too much here because I'm conscious that we're talking an awful lot about data and probably want to see what this car's driven like on the road, so on, and you know, we'll go from there. So, but ultimately, as I expected, we could introduce just a little bit more. I think we're at a sweet spot now. I think pushing it anymore, all we're going to do is create inconsistencies, like I've said. So what we've got here, the dotted line, is what I'm going to call the base file that we've already talked about that did 380 wheel. We're now at 400. This actually did 405 wheel, as I've just explained, but let's call it 400 wheel for argument's sake, because we did let it cool down between runs on the last run there just to get the halo figure. We're just below 400 foot-pounds. We're doing around 390 foot-pounds. Again, for the sake of 10 foot-pounds of torque, this customer's not going to feel that. And if I'm pushing cars to try and hit these dyno numbers, realistically on the road, all that's going to happen is the safety features in the ECU are going to start to back it off once it gets hot anyway. I think we're at a really nice point there. It sounds good. Everything's working nicely. We've got really consistent results. So from here on, I need to do final checks on the data logs from the dyno whilst the lads are taking it off, and then I'm going to take it out on the road. We'll data log it on the road to get the comparison between loaded dyno runs versus what it performs like on the road. Furthermore to that, I need to look at all the part throttle settings, drivability settings. I know that this car will need the, because it's got a sports cat, so it's still MOT compliant, but it is bringing up a cat efficiency code because the cat is a 200 cell, so I'm going to need to work on making sure that they don't get any engine lights. So I'll go and start doing that now whilst the guys are taking it off the dyno, and then you can follow us out on the road. Thank you for watching the video. We've really enjoyed bringing this one to you. Hopefully at some point there's somebody viewing that's got a different colour, because we seem to keep getting grey ones. If you've seen the other video, that's a little bit more in depth, but this gives you a really good overview of what we do here. If you're interested in having your Porsche tuned, please reach out to me or one of the team and we'll make sure that we can put something together for you.